In this video, we're going to be proving that triangles are congruent using the side angle side congruence theorem. So remember what this theorem states is if you want to prove two triangles are congruent, you don't have to necessarily know that all of the corresponding angles and all of the corresponding sides are congruent. If, for example, you know that you have one pair of congruent sides, another pair of congruent sides, and the included angle, the angle in between those two sides that are congruent, then you can conclude that those two triangles are congruent. You don't need to know anything else about the other sides or angles. And so remember, side angle side means that the angle is in between the two sides. So here would be an example of something that's not side angle side. Notice how you still have two sides and one angle, but the angle is not in between the two sides. It's not the included angle that's formed by those two sides. And so this picture would not be an example of the side angle side congruence theorem. So we're going to go ahead and look at what this theorem would look like in a proof. So this is not in your student journal. This is an extra example. So if you don't have access to this extra example, you can always just watch the video or follow along in your spiral notebook. So we have a picture here of some triangles, and we are given a few things, and we're trying to prove that triangle ABC is congruent to triangle CDA. So let's go ahead and let's fill in some of the givens. One thing we are given is that line segment BC is congruent to line segment DA. So I'm going to go ahead and put that in my proof. Notice how B came first and D came first. Those are the 2 points that correspond to each other if we're looking in our triangles. So as we name things, make sure we're putting our names in the correct order. So we're matching up corresponding parts. All right, something else that they give us is that line segment BC is parallel to line segment AD. And you can see that in the picture from these parallel symbols. All right, and so remember to prove triangles are congruent, we're trying to find some other pairs of congruent sides or congruent angles. Now we already know we're going to be using side angle side in this proof. You aren't always going to know what congruence theorem you're looking for. And so you have to, it's kind of like a puzzle that you got to figure out. So what I like to do, this is already given and it's labeled in our picture. So we do have one side. I'm just going to put a little S in the picture. I do have one side that I know is congruent in the triangles. Let's see if we can do anything with this second given statement. Line segment BC is parallel to line segment AD. That's probably important. So if I think about this picture, these are two parallel lines. Now we had a whole chapter on parallel lines and a transversal. Notice this line segment is a transversal that cuts through those parallel lines. So I wonder if we can find any special angle pairs that are formed from those parallel lines in the transversal. And so if I'm looking at some of the angles in my triangle, I see that this angle here in this triangle and this angle here in this triangle, they make a pair of alternate interior angles. They're on opposite sides of this transversal inside the two parallel lines. And I know that alternate interior angles are congruent when the lines are parallel. So I just use the parallel lines to find a pair of congruent angles in the triangle. Let's go ahead and put that in our proof. So to name this angle, I can't just name it angle C. I have to use 3 letters because I have multiple angles at point C. So I'm going to name this angle BCA. Now we got to be careful. B matches with D, remember? So if you look up at your congruent statement, B and D match. So I need to make sure when I name this angle, I name it angle DAC. Those two angles are congruent, and we discovered that because they were alternate interior angles on parallel lines. Okay. So I also have an angle. So I've got a side and an angle. Now we're looking for any more congruent parts. I don't have any more congruent angles. I do notice that the two triangles have one of their sides in common. If you ever see that, that should be a big red flag to you. You're going to be using that side. They share side CA. Well, if they share that side has to be congruent to itself, right? And so I know that they have another pair of congruent sides. So let's put that in our proof. Line segment CA is congruent to line segment AC. And that property that says something is congruent to itself is the reflexive property. All right, so I can see now in my triangles, we have shown that there is a congruent pair of sides, an included angle that's congruent, and another pair of congruent sides. So we had the side, angle, side in that order, right? Look at your picture to look at the order, side, angle, side. So we have proven that the triangles are congruent. Triangle ABC must be congruent to triangle CDA because of the side, angle, side congruence theorem.